Okay, guys, let's move on to problem number 3, part C. This one's quite interesting because it has an absolute value, also known as a modulus. So whenever you have a limit involving a modulus, of course you firstly need to test by plugging in the given value, right, for x. So in this case, this is going to be 1 squared minus 1 minus modulus of 1 minus 1 over 1 minus 1, which is going to be just 0 over 0. Okay, indeterminate form, therefore we need to somehow modify it, right? So the approach for limits that contain absolute values is the following. Firstly, you need to take a look at the absolute value and check what its value is going to be depending on different conditions. So whenever you have an absolute value of something, there are two options for the outcome. Firstly, if the original value inside is already greater than or equal to 0, it should have been, x minus 1. So if the original expression inside is by default greater than or equal to 0, then the outcome of the modulus would also be the same, right? The same as the expression. So if you have modulus of 5, then the outcome is also just 5, right? If you have modulus of 11, then the outcome is also just 11. Therefore, modulus of x minus 1 would be just x minus 1 as long as that expression is greater than or equal to 0. And by the way, whenever you have such an equation, it's best to move this to the other side with the opposite sign. So it's going to be x greater than or equal to 1. So whenever x is greater than or equal to 1, the result of this modulus is just x minus 1. But if that original expression inside, turns out to be negative, so if x minus 1 is less than 0, meaning x is less than 1, then the result of the modulus would be the expression with a minus in front, right? So for example, if you had modulus of minus 5, then you would have almost the same thing, but with a minus. So it's going to be minus 5, which is 5. If you had modulus of minus 11, then it would be the same value, but with the opposite sign. So in the case of x minus 1 inside of the modulus, if that thing is originally negative, in order to turn it to positive, we're going to put a minus in front, okay? So you have same expression with different signs depending on what the value of x is, okay? That's the most important thing to figure out. And from here, what do? You're gonna, so again, that's only for when you're dealing with modulus. You're gonna split your limit, or not exactly split it, but actually evaluate it from both sides, right? So this is the so-called two-sided limit. This is like the final result we're looking for, but we could evaluate it coming only from the left or only from the right, okay? So I typically start with the left-hand limit, but that's not the rule. It doesn't really matter. So I'm going to approach 1 from the left. Whenever we are approaching from the left, we put a minus sign, right? Minus is equivalent to left. So this means that my value is going to be close to 1, but slightly less than 1. It's going to be like 0.9999 something, but less than 1, okay? So I start writing down, I actually copied the full expression for now. I'm gonna copy my limit. But now, because I know I'm approaching 1 from the left, as I said, this means that my x is gonna be slightly less than 1. So when my x is slightly less than 1, then the modulus would give me this value, okay? Minus x minus 1. By the way, I could also rewrite this, let me just quickly do this, as minus x plus 1, just expanding the brackets, or 1 minus x, whatever works for you best. These are all equivalent, okay? So because I know my x in this case will be less than 1, I can safely assume that instead of this modulus, I can just write down 1 minus x and it's gonna work, okay? So that's gonna be, I keep this the same. So x squared minus x minus, and now again, the value of the modulus will be 1 minus x. So I just put this in parentheses. And then the denominator, I'm not going to change, x minus 1. Okay, so from here, it's easy. We just need to calculate things. I just keep going. I have x approaches 1 of x squared minus x. Now just expanding the brackets, minus 1 plus x over x minus 1, which gives us limit as x approaches 1 of x squared. Now these two cancel out, minus and plus x. So x squared minus 1 over x minus 1. Now this numerator has the formula, hopefully you can recognize it, of x minus 1 times x plus 1. That's the difference of squares that I mentioned so many times in these tutorials, over x minus 1. And here is the cool thing, we can cancel these two out. So this leaves us with limit as x approaches 1 of x plus 1. So I can directly just plug in x equals 1 into this. So that's going to be 1 plus 1, which equals 2. Okay? But that's not your final answer. Keep in mind that this is only the left-sided limit. The left-hand side limit is what it's called. But now I need to go back and I need to actually calculate the right-hand side limit. Okay? I know these are kind of long, but once you give them a lot of practice, trust me, they'll almost come automatically to you. You won't have to think very hard of what the steps are. You just need to practice quite a lot. I've practiced quite a lot because I'm not a math prodigy or anything. I've just done a lot of practice and I've just come to understand how things work. Nothing more than that. Okay, so this time we approach 1 from the right, which means we were going to have a plus sign. That's how we indicate it. So if we approach 1 from the right, this means that our x is going to be slightly greater than 1. It's going to be like 1.0001 or something like that. We don't know exactly, but it's going to be slightly greater than 1, which this time puts us in this range, right? So if you're in this range, our modulus would simply equal x minus 1, okay? So whenever I see this, I'm going to replace with x minus 1, okay? Now it's a little bit tricky to see the original. Oh, actually, I have the original expression here, right? So I keep my limit. I copy the rest of the expression, and only for the modulus, I just replace it with x minus 1, okay? I explained the reasoning previously. And now in the denominator, I have x minus 1. Now, you should be very careful. Here, it's a little bit tricky. You might be inclined to just cancel things out. But as I told you in one of the previous tutorials, you're not allowed to cancel things out if you have subtraction or addition. You're only allowed to do it if you have multiplication. In this case, we cannot do this, so I'll just keep going. And now I have limit as x approaches 1 of x squared minus x. I'll just expand the bracket, so this is going to be minus x plus 1 over x minus 1. So this is limit as x approaches 1 of x squared minus x just gives me minus 2x plus 1 over x minus 1. And now, interesting, I can't really figure it out at first glance, right? Because if I plug in x equals 1, then I'm going to get 1 minus 2 plus 1 over 1 minus 1, which is going to be 0 over 0. So I'm not yet ready to plug in the value. I cannot really simplify this further, but the thing at the top looks like a quadratic, okay? I'm not going to spend too much time explaining the quadratic because I already explained the logic behind it in the previous video. So this is actually exactly x minus 1 squared, okay? This is just a formula, but you could also find the roots through the method that I showed you in the previous video. So that's x minus 1 squared over x minus 1. So this time, because this could also be expressed as x minus 1 times x minus 1. So this is something like multiplication of the same thing. I can cancel things out. I can cancel this out with one of the degrees of the numerator, right? Because in the numerator, I basically have this 2 times. I take one of these times, I cancel out with the denominator, and I'm left with limit as x approaches 1 of x minus 1, which is simply 1 minus 1, which is 0. Now, this is my right-hand side limit. So I calculated the two limits. how do I decide if the two-sided limit exists? Because that's what my task was, right? My task was to find the two-sided limit. So here's the rule. The two-sided limit exists only if the separate one-sided limits are the same. In this case, they're not the same, right? So the first one was 2, the second one was 0. Therefore, the two-sided limit does not exist. Now, on the exam, please write it in a little bit more detail. So the way I would write it is I would write this thing equals 2, this thing equals 0. They're different. Therefore, the general limit does not exist. I just don't want to waste time right now, but that's how you do it, right? So once again, you calculate the one-sided limits, you compare them. If they are equal, then the two-sided limit also exists, and it's equal to whatever the value is, right? So if these were both 2, then the two-sided limit would also be 2. If these were both -5, then the two-sided limit would also be -5. But in this case, because they're different, we have a 2 and a 0, the two-sided limit does not exist, and that's your final answer for this problem. All right, guys, I know this can be overwhelming. I hope you're not cramming this the night before the exam or like the day of the exam. That's even worse. But if you give yourself enough time, please trust me, you don't have to be genius mathematicians in order to get it, because I'm not, and I got them just by practicing. And of course, if you have questions, feel free to just email me, text me, and I'll be glad to help.